Hi everyone, I'm going to discuss converting region to degrees and vice versa. So these are the two steps in converting degrees to regions and vice versa. So if we want to convert a degree measure to its region measure, we have to multiply the given degree measure by pi over 180. On the other hand, if we want to convert a region measure to its degree measure, we will multiply that given region measure to 180 all over pi. So in this example, we're going to convert each degree measure here to regions. Okay. So we're going to multiply each value here by pi over 180. And then simplify the fraction by canceling the common factor. So with 45 and 180, the common factor is 45. So this will be canceled. And 180 divided by 45 is 4. So 45 degrees when converted to region measure is equal to pi over 4. So this is pi over 4 regions. So we intentionally write as is the symbol for pi because we are preserving its exact value. So we don't need to convert pi to 3.1416 and then divide by 4. So we will consider this as our final answer. So 200 degrees when converted to radian. So we will just multiply this degree measure by pi all over 180. So canceling the common factor between 200 and 180. So obviously we can cancel this 0 here. And then for 20, when we divide that by 10, so this is 2. And then this would be rather 20 divided by 2 is 10, and then 18 divided by 2 is 9. So the remaining expression is the final answer. So when theta equals 200 degrees converted to region to its region measure, we have 10 pi all over 9. And this is 10 pi all over 9 radians. So for 300 degrees, we will multiply this by pi all over 180 degrees. And common factor between 300 and 180 is 60. So 300 divided by 60 is 5. And then 180 divided by 60 is 3. So this equals 5 pi all over 3 radians. And then lastly, 360 degrees when converted to pi over 180, rather to radian measure. So we have to multiply this by pi all over 180. So we know that 360 when divided by 180 is 2. And then times pi, so this will be 2 pi. So that's how we convert a degree measure to its radian measure. So the next thing that we're going to do is work with converting this time radian measure to its degree measure. So we will multiply each radian measure here by 180 over 5. So this will be canceled, and we know that 180 divided by 3 is 60. So pi over 3 equals 60 degrees. Then 7 pi over 4 multiplied by 180 all over pi. So this pi will be canceled. And then we know that common factor between 4 and 180 is 4. So when 180 is divided by 4, we have 45 degrees here. And then, of course, we will multiply 45 by 7, and that equals 315. So 7 pi over 4 equals 315 degrees. For 11 pi over 6, we will multiply this again by 180 all over pi. So cancel the pi here. And then 180 by 6, we have 30. And 30 divided by, rather 30 times 11 is 330. So this is 330 degrees. Now for 8 pi over 3, this is times 180 over pi. So pi will be cancelled, and then we know that 180 is 1 divided by 3 is equal to 60. And then we multiply 60 by 8. So this is 480 degrees. Meaning class, 8 pi over 3 exceeds 1 rotation. So that's why this exceeds 360 degrees. So in fact, 8 pi over 3 equals 480 degrees. So for 2 pi over 3, we will multiply 180 by pi. So we have 180 divided by 3 here is 60, and then times 2. So 2 pi over 3 is 120 degrees. For 15 pi over 4, we will multiply 180 by pi. So 180 divided by 4 is equal to 45 degrees. And then we will multiply that by 15. So we have 675 degrees. So that's how we convert radian measure to degree measure. Now, it's necessary that you know how to convert radian to degree and degree to radian, because in our next discussions, we will be dealing with an angle in radian measure. So in our previous discussions, we concentrated on an angle in degree measure. So this time, we will be dealing with an angle in radian measure. Okay, so this time we will try to evaluate function values for an angle in radian measure. So since you don't have any idea yet on the unit circle, so what we will be doing is convert this radian measure first to degree and then evaluate its trigonometric function value. So when we say 2 pi over 3, in degree, this is 180 degrees over pi to convert this to its degree measure. So pi will be cancelled, and then this is 60 times 2. So this is 120 degrees. So tangent 2 pi over 3 class is evaluating tangent 120. And we know that angle measures 120 is a non-acute angle. And I was able to discuss to you how to evaluate the trigonometric function values of a non-acute angle. So we will be dealing with its reference angle. And in the previous discussion, for an angle theta measures 120, its reference angle is um 60. So this is the same with evaluating tangent 60. And we know that tangent 60 is a special angle. And if this is 60, then this must be 1, 2 from our previous discussion. And you have to note that angle measures 120 degree. Its terminal side lies on the second quadrant. And we have to note that tangent theta, or particularly here tangent 60, would have a value less than 0. So this has to be negative. And then we consider whatever the value of tangent 60 is. Okay? Because you might be wondering that tangent 60 should be greater than 0. But here we place tangent negative value. We are actually evaluating tangent 2 pi over 3, where tangent 2 pi over 3 equals tangent 120. And the reference angle for 120 is 60. So we're going to work on the trigonometric function value of tangent 60, but we're not going to consider the sine since the theta, or the angle, lies on, I'm referring to its terminal side on the second quadrant. So this should be negative, and whatsoever the value of tangent 60. And this is opposite over adjacent. So this is square root of negative 3. For tangent 60 is square root of 3 over 1 or square root of 3. Now, since we're using this with theta equals 120 degrees, so we consider tangent 60 also because 60 is, or the reference angle for tangent 1 for 120 is 60. But the sign must be negative since a terminal side on the second quadrant would mean a value for tangent less than 0. So that's why we have negative value there. So for 3 pi over 2, so we have to convert 3 pi over 2 to degree measure. So this is 180 over pi. So common factor between 2 and 180 is 2. So this is 90 times 3. So this is 270 degrees. And we are actually evaluating sine 270. In our previous discussion, an angle measures 270 or multiples of 90 is called as quadrantal angle. So particularly for theta equals 270, so its terminal side lies along the negative y-axis. And considering sine theta equals y over r, so we should know what's the value of y and r. So if we select any point again on the negative y-axis, like if we consider 0, -1 here, so we know that y equals x equals 0 and y is -1, and we always consider r as positive. So r from x, the value of x and y equal to -1 and 0, or 0, -1 respectively, so r must be 1. So sine 270 over sine 270 is y over r, which is -1 all over 1, so this is -1. And lastly here, so let's just consider 4 pi over 3 and convert this to its degree measure. So this is 180 over pi. So cancel. So 180 by 3 is 60 times 4. So this is 240. So this is evaluating cosine -240. Okay? And we know that, so we know that the rotation of negative angle is clockwise, and its angle, positive angle or smallest positive angle coterminal with theta equals -240 is 360 minus 240, and this is 120. So meaning, um if this is theta equals -240, this is coterminal with theta equals 120. So we can evaluate, so cosine quantity -240 degrees is the same with cosine 120. So this is equal to cosine 120. So since theta is 120, this is again um a non-acute angle, so we can refer to its reference angle, and its reference angle is 60 degrees. So we'll refer to again this right triangle. So we're going to evaluate this time cosine 60, and cosine 60 is adjacent over hypotenuse. So this is 1/2. So we know that cosine 60 is 1/2, which is the same with cosine 120. But since the terminal side of theta again lies on the second quadrant, only sine and cosecant would have a value greater than 0. With cosine, it's less than 0. So instead of writing 1/2, this should be -1/2. So I hope you were able to convert or understand how to convert radian to degree and degree to radian, because again, as what I was saying in our next discussion, we will be working on an angle theta in radian measure, particularly when I introduce to you unit circle. So bye for now.